Today we are going to start with the next topic, that is of subnetting. Give the concentration over here. What is very, very important for subnetting? What is subnetting? The meaning of this subnetting is, if you have one network, you have one network, and you are going to divide that particular network into the smaller networks. That is called as a subnetting. That is called as subnetting. The meaning of subnetting is called a network is divided into smaller network. A network within a network, that is called as subnet. What is a network within a network? That is called as a subnetting, or we can call it as subnetting is logically division of IP addresses. What is the meaning of subnetting? Network within a network, that is called as subnetting, or logically division of IP addresses, that is called as subnetting. How this subnetting is going to take place? In a particular organization, in a particular company, if you want to have divide the particular IP addresses to the particular routers, in a particular routers, we are going to provide a particular network ID. Different network IDs should be given to the networks, not to the given to the routers, not to the switch. Keep in mind, routers working on inter-networking devices. You have to remember this very, very important point. Routers working on inter-networking devices, switches working on the same network which is having a main server. Only we are going to provide a network ID to the different devices, different routers. If there are two routers are present, if two routers has been present, the router 1 is operating on different network ID and router 2 is operating on another network ID. This is how we are going to provide the particular subnetting to the particular network, particular routers. Got it? Network within the network, that is called as a subnetting. Okay, what it is going to do? If you have an IP address, if you consider the IP address as class A, class B, class C, class D, or class E, total 5 classes are there. Don't consider class D and class E, because these two are reserved for everything multi-class thing. Okay, you have to consider only class A, class B, and class C. You have the ranges. Depending on that, in the IPv4, still many IPs are remaining to give the particular IP addresses to the many of the routers or switches. So in that particular time, what we are going to do, the particular devices, this is what you can consider as a router. This is what we are considered as a router. Got it? And this router is having IP address of this 10.10.0.0.1. This is 10.10.0.2, 10.10.0.3, 10.10.0.4, 5, 6, 7, 8, 9, 10, 11. Up to how many IP addresses? Maximum number is from 0 to 255. You have to remember this. The maximum number for IP address is 0 to 255. Once it crosses 255, the IP address will become 10.10.1.0. The first IP address is 10.10.0.1. Once the maximum number has been crossed, again the next bit, the previous bit will become 1. 10.10.1.0 to 10.1.2 up to 255. Got it? See how many IP addresses we can give to the particular devices. If you had trillions and billions of devices, so we have trillions and billions of IP addresses in your hand to give a particular IP addresses to the particular network. Okay, how we are going to provide this particular IP addresses? How we are going to do a particular subnetting in this particular network? We'll see by using graphically. Okay, just a minute. I will share one. Just a minute. Okay. How we're going to do the subnetting? Okay. This is what? Subnet. We are going to do the subnetting. How we are going to do the subnetting? Okay. If you have the two routers, you have to consider this is router number 1 and this is what? Router number 2. You have to connect these two routers. Okay. And with these two routers, there are number of interfaces. Connection is there. Okay. For this side and for this side and this side and for this side. You have to connect the routers to the many number of computers. These are called as computers. These are called as computers. You are connected. These are called as computers. These are called as computers. Okay. Subnetting is nothing but what? You have to provide a network within the network. Provide a network within the networks. Network within the network is operating only on the router, not on the switch. Not on the switch. Got it? Okay. For this router, this many computers. For this side, this many computers. For this side, these many computers are connected. For this side, these many computers come connected. For these computers, we are going to provide a network. Why? Because this is called as interfacing. This is called as interfacing. Okay. This is called as interfacing. This is called as interfacing. And this is called as interfacing. Got it? And these two is called as interfacing. How many network ID we require? How many network ID? 1, 2, 3, 4, and 5 and 6. Okay. 1, 2, 3, 4, 5, and 6. Total 6 network ID we required. Network within the network we required. Why? Because routers are working on different networks. Routers are working on different networks, but switch is working on the main server only. Okay. For this interface, for this side, the network ID we can call it as, we can take the class A. We can class A, we can take it for a network ID. That is what? How much you can take? That is 10.0.0. This is class A. You can call it as, you can give it as point over here. Okay. And similarly for this side of interface, we can give the class B ID. You can give the class B ID. That is 130.0.0.0. And for this interface, we can give a class C. We can give a class C. What is the class C? That is 200.10.10.0. Got it? You have to give it here point. Okay. That is what? So for this side, you have to give the same class C ID. See here, 200.10.11.0. See how this is class C, we can call it as. See here, 200.10.10.0 is there. So 200.10.11.0 is there. So IP address are not at all same. IP addresses are not at all same. For this, network ID is for class A, for class B for this interface, class C for this interface, and class C for same interface. Got it? Got it? How we're going to call this as class A? Class A. Okay. This is a network ID. How we're going to identify the network ID for class A? The first octet is reserved for network. First octet is reserved for network. Remaining octets are reserved for host. Remaining octets are reserved for host for class A. For class B, 2 octets are reserved for network and remaining 2 are reserved for host. Got it? Very, very important point. Very, very important point. For class C, 3 octets are reserved for network, 3 octets are reserved for network and 1 octet is reserved for host. 1 octet is reserved for host. Similarly, for 3 networks are reserved for network and 1 octet is reserved for host. By using this, how you are going to provide a particular IP address to particular individual users. You can consider the number of computers connected in this side is 20. The number of computer connected in this side is 10. The number of computers connected in this side is 50. And number of computers connected in this interface is only 4. Only 4. See, only 10 IPs are required for this many computers. Only 20 IPs are required for these many computers. Only 50 IPs are reserved for required for these many computers. Only 4 IPs are required for these many computers. So what about remaining IPs? They are wasted. They are wasted. Got it? So many of the IPs are going to waste like this if you are using millions and trillions of. Who is this? Don't disturb. Mute yourself. Okay. Okay. How are you going to provide the 10 computers for this class A IP address? This is nothing but 10.0.0.0. The IP address number 1 for computer number 1. Next 10.0.0.1. Similarly 2, 3, 4. Similarly, your goes on giving the IP addresses up to 255. Up to 255. Once it becomes 255, this block will become 1. See, only 10 computers are there. We can give only 10 IP address. Remaining are wasted. So how many IPs are remaining? Just imagine. Just imagine. So okay, only 1 octet is reserved for network and 3 octets are reserved for host. Got it? Similarly, for 50 numbers of computers, we can give this for 2 octets are reserved for network and remaining 2 are reserved for host. See, for class C, the number of IPs are less. Less is nothing but up to 255. Why? Because the 3 octets are reserved for network. Only 1 octet is reserved for host. Got it? So this class C IP address is used for a smaller network area. It is used for a smaller network area. For class A, it can be called as a large network area. Getting the point? Getting the point? Class C is used for a large network area. Sorry, class C is used for a small network area and class A can be used for a large network area. Got it? So this is how we are going to do the subnetting. We'll take one example how we are going to do the subnetting. How we are going to do the subnetting. Okay, got it? Again, you have to draw one diagram over here, that is R. Similarly, it is connected to R. It is connected to R. Okay. After this, there will be a interconnection is there, interface is there. The number of computers are connected in this side, and in this side, and in this side. Okay. Number of computers are connected. Number of computers for all the interfaces, same interface. Okay. Again, here it is there. Got it? Number of computers connected is 10 here. Number of computers connected is 40 here. Number of computers connected is 30 here. Number of computers connected is 20 here. Got it? We'll take a one IP address, the one IP address that is of class C. Okay, class C, that is of 197.10.10.0. Okay, you have to apply your point. Okay, so one more thing is very important. One more thing is very important. If you make it oblique 24, why? Because 24 for class A, oblique 8 is there, oblique 8 is there. For class B, for class A, there will be a oblique 8. For class B, there will be oblique 16. For class E, C, oblique 24. For class D, oblique 32. Got it? If there is a oblique of 24 is there, so there is no subnetting has taken place. If it is more than this, if we have a number more than this, so already subnetting has been done. Already subnetting has been done. How we will see here? You consider the IP address for this is 197.197.10.10.0 oblique 24 slash 24. Okay. Okay. How many network IDs are present for this? Class C? Class C, the 3 network is reserved. 3 network is reserved for 3 octets are reserved for network, and only 1 octet is reserved for host. Only 1 octet is reserved for host. This is what a first step. This is the first step. And what is the second step? What is the second step? How many bits, how many octets are reserved for host? The only 1 octet is reserved for host. At that time, what you have to do? You have to make this as binary number. You have to convert this one. Sorry, you have to convert the host into the binary. You have to convert this into the binary. How we are going to convert? It is of 8 bit. It is of 8 bit. So that becomes 197.197.10.10. You have to write 8 zeros. 1, 2, 3. Sorry. 5, 6, 7, 8. Got it? Got it? For class C, the 3 octets are reserved for network and 1 octet is reserved for host. You have to do the subnetting. Whenever you are going to do the subnetting, you have to see only the host part. How many octets are reserved for host part? You have to convert those into the binary, into the 8 bits. That is 4 zeros plus 4 zeros. That becomes 8 bit. And the step 3 is what? The step 3 is what? There is a formula for converting the particular IP address into the subnetting. That is what? 2 raised to n minus of 2. You know this. 2 raised to n is number of computers connected. Minus 2 is nothing but what? I already told you that the minus 2 stands for inner IP address. The network ID is reserved and the broadcast ID is reserved. This is reserved part. This one is what? Reserved part. This one is what? Reserved part. Network ID is reserved and the broadcast ID is reserved, so that we are making minus of 2. You have to see the maximum number of computers in here. How many the router is having connected? The maximum number of root computer is 40. So you have to make it greater than equals to 40. You have to consider the maximum number of computers where it is connected. You have to make it 40. You have to make it 40. Okay, 2 raised to n minus of 2 greater than equals to 40. It should be greater than equals to 40. You can take the number of n is 1, 2, 3, 4, 5, 6, and so on. Got it? You have to substitute 2 raised to 1. 2 raised to 1 minus of 2. Is it greater than equals to 40? No. Got it? 2 raised to 3 minus of 2 is greater than equals to 40? No. You have to consider 2 raised to 6 minus of 2. How much is becomes? 2 raised to 6 minus of 2. How much is this? 2 raised to 6 minus of 2. Is it 64 minus of 2? How much is this? That becomes 62 is greater than equals to 40. Got it? Got it? So you got the number of n. you got the number of n. N is equals to 6. If you do it 2 raised to 5, 2 raised to 5, you'll get the answer as 30. Is 30 is greater than equals to 40? No, you have to cancel it. Next, you have to consider the next number. 2 raised to 6 minus of 2 is equals to what? 64 minus of 2, that is 62 is greater than equals to 40. So you have to consider the value of n is 6. The value of n is 6. अब वे है, you can consider the value of n is 6. Now the process starts. Now the process starts. How we are going to do the subnetting? How we are going to do the subnetting? You consider that is n is equals to 6. You consider the n is equals to 6. Got it? The what is your IP address? 197.10.10. How many? You are considering the one host as, you are considering one host as, that is 8-bit of zeros. That is 8-bit of zeros. Got it? Got it? Okay, got it. 4 plus 4, 8. What is your n? What is your n? This is very, very important. How we're going to do the subnetting? How we're going to subnetting, and those subnetting will be given to the particular IP addresses. Okay, you are considering IP address as class C IP address. Okay, you are requiring the IP addresses for, you are requiring the network ID as 4. Will you get the 4 number of network ID for considering this class C IP address? 197.10.10. You are making as host as 000. Got it? Got it? Okay. After this, what you have to do? After this, what you have to do? You have to write 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, up to 2 raised to 7, up to 2 raised to 7. What the value it becomes? 1, 4, 8, 16, 32. Next. 1, 2, 4, 8, 16, 32, 64, 128. Got it? Got it? So how are we going to make it? How are we going to make it? So you have to write it again. You got it. So 127.10.10.00000000. Your n value is 6. Your n value is 6. Okay. Your n value is 6. You have to count from right hand side to the left hand side. This is 1, 2, 3, 4, 5, 6. After 6, you have to make these 2 zeros as 1. After 6, you have to make these 2 zeros as 1. Getting the point? Getting the point? How are you going to do the subnetting? Your n value is 6. Your n value is 6. You have to count from right hand side, that is 1, 2, 3, 4, 5, 6. You have to make it as 1. That is 197.10.10.11000000. This is n is equals to 6. And after this zeros, you have made it as 1, 1, 1, 1. What is the value of this? What is the value of this? You already did it. 1, 2, 4, 6, 1, 2, 4, 8, 16, 32, 64, and 128. You have to, this number for 1 is 128, and this number for 1 is 64. Got it? Got it? 1, 1, 1, 2, 4, 8, 16, and 32. Your n value is 6. You have to count from right hand side to the left, that is from 6, and remaining 2 zeros will made it as 1, 1. We are giving these 2 zeros to the network. We are giving to these 2 zeros to the network, so that we are getting one network ID. That is called as a one network ID, that is called as subnetting. 128 plus 64, how much it is? 128 plus 64, anyone? 128 plus 61, 64. झोपलंस का सगळं? 128 plus 64. One 128 plus 64. This becomes 192. No use. 197.10.10. This becomes 192. This will become 192. This will become 192. So we got the first the subnetting ID, the first subnet ID. How are you going to get the subnetting ID? You have to make this first, these three and can be reserved for network. So we can make it 255 network 255 dot 255 dot 255 dot 192. This is your subnet mask. This is your subnet mask. If you want to get the ID for this subnet ID, what you have to do? If you want to write a subnet ID for this, you have to make it 197.10.10.0 oblique. What is there? Here it is 24. You have to make it plus 2. Why? Because you are given these two. You are given these two as network. So you have to make it plus 2. That is becomes 26. That is becomes 26. The subnet ID for this is 197.10.10.0 oblique 26 oblique 26. Okay, this is subnet ID 1. This is subnet ID 1. The ID 1. Subnet ID 1 is what? Subnet ID 1 is what? 197.10.10.0 oblique 26. Okay, for ID2 you have to just make it ID2. What you have to do it for ID2? What you have to do it for ID2? Just you have to add the 64 over here. Just you have to add the 64. 197.10.10.64 oblique 26. Okay, got it? The first ID of this. Okay, after that you have to add it 64 here. ID3. ID3, that is 197.10.10. That becomes 128 oblique 26. Got it? This is ID3. This is ID4. You have to give it ID4. ID4, that is 197.10.10.192 oblique 26. Got it? Got it? How are you going to get the ID? How many IDs we received while doing the subnetting? 4 IDs. 4 IDs. The first ID for this 197.10.02 oblique 26. ID2 is 197.10.10.64. That is your second ID. And the third ID is 197.10.10.126 oblique 26. That is third ID. And ID4 is 197.10.10.192.26. After adding this 192 to 64, how much it becomes? How much it becomes? So it goes more than 255. I think it goes more than 258. It becomes 258. What is your range? That is from 0 to 255. The range is 0 to 255. So it is going beyond that. It is going beyond that. So you can't consider. So we get For class C, we are getting total 4 IDs. We are getting only 4 network IDs, subnetting IDs. We can call it as a 4 subnetting IDs we are getting. Got it? How many IDs we require? 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 We require total 5. So we are not getting the total 5 IDs. So move from we can move from class C to class A. We can move from class C to class A. If you want to require more and more number of network IDs, if you want to require a more and more number of require IDs, so the class C will be operated on maximum number of, which is a larger network area, and class A will be operated on larger network area, and class C will be operated on small network area. Got it? Got it? How we are going to get the particular net subnetting ID? This is what practically we are doing this. If you want to practice, you can take the class A network. And try it. Got it? How are you going to do this particular network ID? Okay. Will you try for class A? There is a homework for you for class A. And how we are going to provide subnet masking? How we are going to provide a subnet masking? Already we are discussed with this. Subnet masking. We take a class A IP, that is 115.10.10.20. This is what? Class A. This is the IP address is class A. How many network IDs are reserved? The first. Only one network is reserved for class A. Remaining are reserved for host. Remember this. The first octet is reserved for network, and remaining octets are reserved for host. This one is what? Network. And these three are host. Okay. What we can do? You have to convert this class A IP address into the subnet mask. What we can do in this is, one octet is reserved for network, and 3 octets are reserved for host. Okay. Only one is reserved for octet network, and remaining 3 are reserved for host. So what we can do? You have to do the network is 8 bits. It is of 8 bits. Is this 8? 4 plus 4, 8. Dot. Your to remaining will be 0. Remaining will be 0. Dot. Again 0. 8 0 should be required. Again 0. Got it? This one is maximum. If you want to make it as 2 raised to 0, so maximum number is, that is of 255. Dot 0 0 and 0. Got it? This number is called as subnet mask. This is called as what? Subnet mask. Got it? You have to see how many octets are reserved for the network. If only one network is reserved for only one octet is reserved for network, you have to make all the binary numbers as 1. And remaining you can make it as 0 0 for host. That is becomes 255. Maximum number is 0 to 255. So 255.0.0.0, that becomes your subnet masking. Take it for class B. Take it for class B. What is a class B? What is class B? 2 octets are reserved. 2 octets are reserved for network. Remaining 2 are reserved for host. Remaining 2 are reserved for host. So you have to make it as the first 2 bits 1 1 dot, next 1 1 1 1 1 1 8 bits dot. You have to write remaining 8 bits as 0, remaining 8 bits as 0 dot 0 dot 0 dot 0 0. What it is? What is this subnet mask? What is this subnet mask? That is 255 dot 255 dot 0 dot 0. Got it? This is the subnet mask for class B. This is the subnet mask for class B. What about class C? What about class C? For class C, what is the subnet mask? That is 255 dot 255 dot 255 dot 0. Why? Because the 3 octets are reserved for network, 3 octets are reserved for network, and 1 octet is reserved for host. 1 octet is reserved for host. Whenever you open any device of a particular computer, you came to know the particular IP address. You will came to know the particular IP address. Which IP address is belongs to which class? Which IP addresses belongs to which class? That you came to know. That you came to know. For class A, one network ID is reserved for network and remaining are reserved for host. For class B, 2 octets are reserved for network and remaining 2 are reserved for host. Or for class C, 3 octets are reserved for network and 1 octet is reserved for host. This is how we are going to do the subnet masking. We are going to do the subnet masking. Got it? Got it? How we are going to provide this subnet masking to individual devices or individual computers. Okay? Okay? Okay. I hope you understood this subnet masking. Very, very important point is IP addresses, that is IPv4, IPv6, and subnet masking. IPv4, IPv6, and subnet masking. Very, very important for this unit is in transport layer is IPv4 and IPv6 and subnet masking. So last part is remaining. So we'll complete this unit tomorrow and we'll start with the unit number 6. Okay. Thank you.